Hello everyone, let's continue the lesson on the Laplace transform. Previously, we have counted the solving on a first order ordinary differential equation in chapter 1 and second order ordinary differential equation in chapter 2. But now we would like to study on a Laplace transform where the Laplace transform also can be used to solve that particular problems. The main basic application of the Laplace transform is on electric circuit with any number and type of a direct current, and any number of resistor can be analyzed with the Laplace transform. Now let's focus on the table of 3.6, table of a Laplace transform. You can see that on the left hand side is the function in ft, and then the function on the right hand side is in terms of fs. So if you are given the function of ft and then you want to get the function of fs, so we call this one as a Laplace transformation. Alright. So before we go further on a solving on a ODE, we need to understand how to transform the Laplace, how to transform the equation on a single function. For example, if you have the ft and then your ft is a single number, for example 2, so when you want to convert to the Laplace in terms of fs function, so you will get your function is 2 over s, and then the general way, if you have here is your ft and here is your fs. Alright, so you will have a, and then here you just take it a over s. So this is the most simplest function. The second one is a polynomial. If you have your polynomial with function of t power of n, where n can be 0, 1, 2, 3, alright, so you will get n factorial, and also you have s n plus 1. So for this one, what you need to understand is you need to determine the value of n over here, because of you need to put here as a n factorial, and then you need to separate the power with n plus 1 over here. For example, if you have one function in terms of t power of 3, and then if you want to convert into the fs function, so you need to determine your n first, and then you take it the n and put the factorial, and then you need to have s and n plus 1. Alright, so what you need to do is you need to determine what is the 3 factorial. 3 factorial, you can press your calculator, or it's working like this: 3 multiply with 2 multiply with 1, and then you have s power of 4. So you need to calculate this one. You got c s power of 4. So this is the answer for the polynomial. And if you have the function of ft in terms of exponent, for example, you have at over here, so directly in fs you will get 1 over f minus a. So you should consider this one. If your a is negative and then here is positive, and if here is a positive, then here is negative. For example, you have one function of ft, alright, and then let's say you have exponent 3t, so you will directly get in fs is 1 over s minus 3. You just replace your a over here. Alright, it's similar to that one. If you have your ft in terms of exponent negative 2t, and then you will get your fs, which is s plus, because we have a minus over here, so it's changeable for this one, so it's a plus 2. So this is the answer. This is the function of ft. So now let's go the function of sine. You will have sine at, and then also you need to consider this one. You need to identify what is the value of a over here. Alright, so in the function of fs, you will get a s squared plus a squared. So let's say if you have sine 2t over here, so your a is 2, and then you will have 2 over here s squared plus 2 power of 2. Okay, let's go to the another one. If you have cos 80, so the changeable for this one is only you need to have s over here, s squared plus a squared. Also, you need to understand how to identify the value of a. For example, if you have cos 3t, so directly you will get s over s squared plus 3 squared. So this is the answer. Okay, for the sine hyperbolic, it's just change in terms of the sign at the denominator. If you have sine hyperbolic to t, and then your answer is a, which is 2, and then you will have s squared, and then it's only change for the sign over here to power of 2. Alright, so remember that if you have the hyperbolic, then the changes over here is only at the denominator. Let's say if you have cos hyperbolic 3t, also the changes only it's happen on the denominator. So when you have a cos over here, you need to remember that you will have s squared, and then you need to have minus with a squared. So this is the answer for the sine and cos hyperbolic. Okay, so we will go for another function, which is function in terms of u t minus d. Alright, so you will get directly exponent negative sd over s. Okay, let's say I give to you the function of u t minus 2. So directly you just determine that over here is your d. So you will have negative 2 s over s. Okay, and then if you have t minus 1, remember it will change accordingly to this one. So you will get exponent s over s. Alright, okay, so if you have in terms of delta t minus d, only you will have a single function exponent negative sd. Alright, let's say you have a function of delta t minus 1, so you will get exponent negative s. Okay, so finally for the table 3.6, if you have delta d, so the answer is 1. Hello everyone, let's do some exercise. Alright, okay, so we have given to you the list of the function of ft, so you need to transform to the function of fs by taking the Laplace. Okay, for the first one, the answer should be 2 over s. Alright, and then for the second one is a polynomial. You need to remember that 2 over 3 here is only the constant, so just put outside over here, and then you just need to bother with this function. So this function is 4 factorial over t, it's not t, it's actually the s. Alright, s 4 plus 1. Okay, 4 plus 1. So the answer is 2 over 3 here. So you need to calculate 4 factorial. So 4 factorial is what? 4 times 3 times 2 times 1. It's actually 24. And then here is a s power of 5. Okay, so you can simplify it. So you got 1 over here. You got over here 8. And then the answer is 2 multiplied by 8 is 16 over s power of 5. Okay, what about if you have the function of exponent? As I said to you, you need to check whether here is positive or not. If it's positive, then the answer, the denominator must be negative. And then for this one also is the same thing. So it's actually the constant outside, and then you will have 1 over s minus a, 3 over 2. Okay, the difference between the positive or negative in the denominator, you need to check xa. Alright. Okay, so let's go to the function sign. The function sign, as usual, 1 over 2 here is actually the constant, and then you just need to determine the a over here. So your a is over here, and then so you just need to have 2 over 3 over here, and then you have s should be plus with a, so it should be s squared plus a squared. So you just put a over here, so you got this one. And then the cos, okay, the cos must comes with s over here, and then your a is 4, so you will have s squared plus 4 squared over here. Okay, the sine hyperbolic, the 3 over here is a constant, and then the difference only we have your a, so your a for the this function is 0.5, and then we have s squared. We need to be careful here because it's minus, since the function is the hyperbolic function, so 0.5 squared over here. And then for this one, 1 over 2, and then cos hyperbolic, you need to remember that we have s over here, and then we have s squared minus with 1 over 3 squared. Alright. Okay. And then for these functions of u, so this is actually your d, and then the answer is exponent. Okay, since here is negative, and then the power also negative ds, so we have 1 over 2s, and then we need to over with s. And then for the second last, you need to determine your d over here, and directly we get answer negative 3 over 2s. And then finally we have 3 outside, so for the delta t we have 1, so the answer is 3. Alright. Okay, good luck.